Hello, scholars. We're going to begin our discussion of Chapter 2 with definitions for instantaneous speed and average speed. You probably already understand how to compute average speed. If I drive 200 miles, for example, and it takes me 4 hours, I can divide to find my average speed. So the distance that I drive, 200 miles, is my numerator. I'm going to divide by the total time it takes me, so 4 hours, and I get units of miles per hour and a final answer of an average speed of 50 miles per hour. So to find average speed, I compute average speed by dividing distance traveled by the time interval, by elapsed time. So you see there's a place on your notes paper for you to fill that in. Average speed can be computed by, and feel free to use an expression like this, or feel free to write it out in words, that's your choice. Dividing distance traveled by elapsed time. Just to contrast with average speed, if at some moment during my trip I looked down at the speedometer and said 65 miles an hour, or maybe I was passing a police officer with a radar gun and I got radar gunned and the reading was 75 miles per hour, that's my instantaneous speed. So speed at one particular moment is instantaneous speed. Average speed is distance traveled divided by the time that it takes. So we'll do an example next of computation of average speed. You'll want to write in this example on your paper as we go. So let's say I have a rock that's going to fall from a cliff, and I happen to already know a formula for the distance that it's traveled. So you can see the formula here. The distance traveled is a function of the time since the rock started falling, and I have y equals f of t, which is 16t squared. To figure out average speed, I need to find total distance traveled and divide by the time that the rock has been falling. So at 0 seconds, the rock has fallen 0. I could even plug in 0 for t into this formula, and I have a distance of 0. After 2 seconds, you'll notice I've plugged in 2 to the formula here, and I find out that after 2 seconds, the rock has fallen 64 feet. So my total distance traveled is 64 feet. It's taken 2 seconds to fall that far, so 0 seconds to 2 seconds as an interval of 2 seconds. And I can write that same fraction, 64 divided by 2. I have units of distance over time, because I'm dividing a distance by a time, and I end up with an average speed of 32 feet per second. The instantaneous speed is a different matter. If I want to know the speed of the rock at one particular moment, let's see what we're going to do. I'd like to use that formula that I use for average speed, because it seems like it's a speed formula, I should still be able to use it. But the problem is, my time interval now is reduced to 0. I care about the speed of the rock at exactly 2 seconds. So not between 2 seconds and 3 seconds, or between 0 seconds and 2 seconds, but between 2 seconds and 2 seconds. Well, when I go to subtract, the difference between 2 seconds and 2 seconds is 0. I'm going to end up with a 0 in my denominator, which I know I'm not going to be able to evaluate. I won't be able to evaluate a fraction that has a value of 0 in its denominator. So this is going to be my approach, and you can see I've written in for you in your notes. What I want to do, I'm going to take that same formula, but instead of using 2 seconds and 2 seconds as my two time values, I'm just going to pick 2 seconds as the first time value and something really close to 2. So I'm going to say 2 plus h, and I'm going to let h be a very, very, very small number. So you can see here I have set up that same sort of fraction where I have the change in the distance, the total distance traveled in the numerator up here, and I have the change in the time interval in the denominator. But instead of using exactly 2 and exactly 2, I'm going to say that the first time value I care about is 2, and the second time value I care about is 2 plus h. So I could type this into my calculator, or maybe write a computer program, and let the computer or the calculator use smaller and smaller and smaller and smaller values of h. And let's see if I can figure out what value I'm going to approach. What speed am I going to come to if I could let h get smaller and smaller and smaller? I can't actually let it be 0, but I can let it get closer and closer.